before clocks, before calendars, before hours and minutes were ever named. There was rhythm, the gentle rising of the sun, the quiet fading of the stars, the hush of night folding over the land. Long ago, our ancestors lay beneath the open sky and watched. They noticed that the world moved, slowly, softly, with a kind of order. The moon waxed and waned. The tides came and went. The shadows stretched and shrank, as if breathing with the earth. These were the first signs of time, not as numbers, not as rules, but as a whisper. Timekeeping began not with tools, but with wonder, a sense that things returned, that mornings followed nights, that something greater pulsed beneath all life. And so, this story is not a tale of machines, though there will be many. It is a story of human curiosity, of how we learn to measure the fleeting, to give shape to the invisible, from stone circles under open skies to silent crystals ticking in satellites above us. This is the story of how we tried, gently, imperfectly, to hold time in our hands. So close your eyes, or let them rest on the ceiling. Breathe slowly. Let the moments unfold. Let the story drift in. Like the turning of a great, quiet wheel, we begin, as all things do, with the light of the sun. Imagine standing in a vast open plain. There are no buildings, no wires, no beeping watches or glowing screens, just you, the sky, and the slow stretch of a shadow across the ground. This was how it started. Thousands of years ago, before writing, before math, people watched the sun move through the sky each day. They saw how their own shadows danced, long in the morning, short at noon, long again by dusk. They began to understand. Time could be felt, seen, even measured, with patience. In Africa, stone circles, some older than Stonehenge, were arranged to catch the solstices. In what we now call Nabta Playa, stones stood as early markers of celestial alignment, placed by people who read the sky like a storybook. Elsewhere, in Mesoamerica, the Maya tracked Venus and lunar eclipses with such care that their calendars rivaled ours in precision. They watched patterns across generations, crafting a map of time that connected harvests, rituals, and rain. Even without tools, our ancestors were already timekeepers, gazing upward, feeling the earth's cycles deep in their bones. The tilt of the sun told them when to plant. The return of certain stars told them when to travel. This was a time of listening, and while the days were long and the nights mysterious, people slowly learned to read the rhythms. Time was not a number, it was nature's whisper. As centuries passed, the urge to mark time more clearly grew. In ancient Egypt, obelisks, those towering stone spires, were not just monuments. Their shadows traced the hours across the ground, silently dividing the day into portions. High noon became a moment of alignment. The changing lengths of shadow marked the steady pace of the sun. The Babylonians, brilliant sky watchers of Mesopotamia, developed early star charts and divided both the day and the night into 12 parts, giving us the number 60 as the base of timekeeping we still use today. 60 seconds, 60 minutes. It began with them. In ancient Greece, sundials became refined works of science and art. Some were carved into marble, others set into public squares. A gnomon, a stick or wedge, cast a shadow that crept around a circular path, telling time not with sound, but with silence. Even in cloudy lands, people found ways. The Romans built portable sundials to carry with them, early pocket clocks made of bronze and ingenuity. But sundials had limits. When the sky turned grey or night fell, the shadows vanished. And so, timekeepers looked to new elements: flowing water, drifting sand, the steady burn of flame. But we will come to those soon. For now, let us rest here, in the sun, as the shadow gently moves. When the sun could not be seen, when shadows disappeared into dusk or cloud, time still moved. And so, humans turned to water. In ancient Egypt, clay vessels with small holes allowed water to escape, drop by drop. As the level fell, marks inside the container told how much time had passed. These were clepsydras, water thieves they were called, quietly stealing moments. In Babylon and China, water clocks evolved into more complex systems: gears, bowls, spouts. Some even chimed or moved figures as time flowed. Imagine a night watchman listening to the steady drip, counting time not with numbers, but with sound. In Islamic lands, timekeeping became both art and devotion. Astrologers and engineers built intricate water clocks in mosques and courts. Al-Jazari, a brilliant inventor from the 13th century, created a clock powered by flowing water and adorned with birds and automata, machines that seemed alive. These clocks did not tick, they did not ring, they whispered, and in their quiet persistence, they taught us that time does not stop for darkness. Water, essential to life, was now essential to knowing when to pray, when to rest, when to rise. A quiet stream, marking the hours, in places where water froze, where darkness lasted long, people lit time on fire. The candle clock was simple, yet beautiful. Wax was marked in even lines. As it melted, time disappeared inch by inch. In medieval monasteries, monks used these to wake at intervals for prayer. In ancient China and Japan, incense sticks burned with knots at fixed lengths, releasing fragrance as time passed. Imagine sleeping in a room filled with the scent of lavender and myrrh, each breath a second, each scent a reminder that night is not still, but slowly turning. Then there was sand, the hourglass, 2 glass bulbs, a narrow neck, grains falling in silent surrender. In ships, where water clocks would slosh and candles would flicker, hourglasses kept time steady. They marked the watches of sailors, the rhythm of tides. They measured sermons, cooking, even court sentences. A prisoner might hear his fate read as the time of 1 glass turned twice. These tools were quiet companions. They did not command, they reminded that even in silence, time is always falling, always glowing, always gently moving on. It is night in a stone abbey, cold, still. A bell rings once, then twice. Somewhere, a monk rises from his straw bed to chant a prayer. This was the rhythm of the Middle Ages, not hours as we know them, but canonical hours, times for devotion divided by the church. Matins before dawn, lauds with the sunrise, vespers at twilight, compline before bed. Before clocks were common, these divisions of time were kept by bells, tower bells, handbells, bells pulled by cords in the dark. The first mechanical clocks appeared in these monasteries, large, weight-driven machines that turned gears and rang bells at intervals. They had no faces, no hands. They were heard, not seen. These early machines were often built by monks, who were also blacksmiths and mathematicians. Their goal was not perfect accuracy. It was obedience to rhythm, to order, to God. In towns, clock towers began to appear. People gathered not to look at the time, but to hear it. The ringing marked when to open the market, when to light lamps, when to rest. Time was still collective. It belonged to the village. The bell was its heartbeat. And slowly, that heartbeat became mechanical. The 14th and 15th centuries brought the rise of mechanical marvels. Clocks were no longer only for monks. They adorned town halls, castles, cathedrals. Huge faces, gilded hands, painted signs of the zodiac. Some had moving figures, roosters that crowed, kings that bowed. The secret was the escapement, a clever mechanism that allowed gears to move in steps, not all at once. With each tick, time was released. The escapement made it possible to measure time in hours, then minutes. Artisans became engineers. Blacksmiths became clockmakers. In Nuremberg, in Milan, in London, workshops hummed with metal and motion. Portable clocks emerged, boxes of brass and glass, wound with keys. Though not yet precise, they brought time closer to the person. A nobleman might carry a timepiece as a symbol of learning and power. This was also the age of exploration. Sailors needed accurate time to navigate. Maps and stars were not enough. They needed clocks that could survive at sea. And so, the dream began. To make time portable and precise. It would take centuries to reach that dream, but the ticking had begun. It begins with a boy in a cathedral. Galileo Galilei was just a teenager when he noticed something strange. A large lamp, suspended from the high ceiling, had been set into motion, perhaps by the wind, perhaps by a curious hand. It swung back and forth, back and forth. And as it did, Galileo watched, not with idle eyes, but with wonder. He compared its motion to the rhythm of his own pulse. He noticed something that would change the future of timekeeping. No matter how wide or narrow the swing, the time it took for each swing, each period, was the same. This was the principle of the pendulum. Years later, Galileo would sketch plans for a clock that used a pendulum to regulate its movement. He would not live to build it, but his insight laid the groundwork for the most accurate timepieces the world had ever known. In 1656, Christian Huygens, Dutch mathematician and scientist, built the first working pendulum clock. It was tall, heavy, and elegant. Inside, the pendulum's slow, deliberate swing controlled the release of the gears with steady, graceful precision. For the first time, clocks could measure seconds. Time was no longer just a suggestion. It became sharp, fine, exact. A pendulum clock might lose just a few seconds in a day, a miracle for the age. Soon, pendulum clocks stood in homes and halls, chiming softly on the hour. Grandfather clocks ticked in the corners of parlors. The swing of the pendulum echoed through the quiet of evening. Tick, tock, tick, tock, like a breath, like a lullaby. Time was no longer locked in towers. With gears made finer, springs wound tighter, and hands that swept gently across faces of silver and gold, time became something we could carry. the pocket watch was born. In the 16th century, European watchmakers began crafting small, portable timepieces. At first, they were egg-shaped or cylindrical, worn as pendants or tucked into robes. Their dials were often simple, with just an hour hand. Minute hands would come later. These early watches were not precise. Some lost an hour or more each day, but that didn't matter. What mattered was the feeling. To hold time in your hand, to carry it quietly in your coat, to open a polished case and see the delicate motion of a world inside. By the 18th century, pocket watches became status symbols. Nobles and merchants alike carried them, their chains gleaming against velvet waistcoats. Craftsmen engraved their cases with initials, flowers, constellations. Inside, tiny mechanical hearts ticked softly, hidden music. Watchmakers in Switzerland, France, and England refined the craft. New escapements, jeweled bearings, and better metallurgy made watches more accurate, more durable, more lovely. No longer did one need a bell to know the hour. No longer did one need to look to the sky. Time had entered the pocket, quiet, personal, near. And though these watches did not shout, they spoke gently to their owners, reminding them, softly, that time is always with us, folded in the lining of a coat, resting against the heart. It began with steam. In the 19th century, railways spread like vines across continents, iron tracks stretching over hills, through cities, connecting places once thought distant and separate. Trains moved faster than anything before. They left one town and arrived in another, and the sun might still be in the same place in the sky, but towns each kept their own time, set by local noon, the moment the sun reached its highest point. This worked, until it didn't. A train scheduled to leave one station at 12 o'clock and arrive at another at 12:05 might, by local clocks, seem to arrive before it left. Confusion reigned. People missed trains, schedules clashed, commerce hesitated, and so time itself had to change. In 1884, representatives from around the world gathered in Washington, D.C. for the International Meridian Conference. There, they agreed to divide the world into 24 time zones, each centered on lines of longitude. The prime meridian, 0 degrees, was set at Greenwich, England. Greenwich Mean Time became the anchor. Trains could run on schedule. Telegraph operators could sync their wires. Cities could chime in harmony. It was the first moment that the entire planet, in a way, listened to the same clock. And behind the scenes, new inventions helped keep this shared time. Telegraph lines carried time signals across continents. Railroad watches, especially crafted and rigorously tested, were issued to conductors and engineers. Accuracy became essential, and the world ticked forward with renewed order. For the first time in history, everyone knew what time it was, and though that agreement came from necessity, it also brought a new sense of unity. The globe was turning, and we were, gently, turning with it. Tick, tick, tick. And then, something almost miraculous, a clock that no longer needed gears, pendulums, or springs, a clock that ticked because a tiny crystal was singing. In the early 20th century, scientists discovered something remarkable about quartz. When electricity passed through it, quartz vibrated at a steady, reliable frequency. Not fast, not slow, just steady. about 32,768 vibrations per second. This became the heartbeat of a new kind of timekeeping. In 1927, the first quartz clock was built. It wasn't small. It filled an entire cabinet, but it was astonishingly accurate. Unlike mechanical clocks, which could be affected by humidity, friction, or temperature, quartz clocks kept time using the quiet certainty of a crystal's vibration. And as electronics advanced, quartz clocks shrank. By the 1960s, they fit in laboratories. By the 1980s, they fit on wrists. Wristwatches, once the domain of gears and winding keys, became digital. They displayed glowing numbers instead of hands. Children could wear them. Athletes could time races. Alarms could be set with the press of a button. Quartz time was democratic, cheap to make, easy to use. It ticked not with sound, but with silence, invisible, unshakable rhythm. And while most never saw the tiny crystal hidden inside, it was there, vibrating with purpose, dividing seconds with precision, humming quietly beneath the face of the clock. It did not need to be wound. It did not need to be watched. It simply kept going. Time had become a pulse, a whisper of electricity. The old ticking faded, and in its place, a smoother beat began. There is a clock that does not tick. It does not swing. It does not drift. It measures time not by the sun, nor by a spring, but by the behavior of atoms, tiny, invisible, constant. Welcome to the age of atomic time. In the mid-20th century, scientists asked a quiet question. What if we could define a second, not by Earth's rotation, but by something even more stable? The answer lay in the element cesium. When cesium atoms are exposed to certain frequencies of microwave radiation, they resonate, shifting between energy states at an exact and predictable rate. That rate is not guessed. It is not estimated. It is counted. Every second, cesium ticks through 9,192,631,770 oscillations. In 1967, the world agreed. This would be the new definition of a second. Atomic clocks were born. At first, they were housed in laboratories, quiet rooms filled with wires, magnets, and sealed metal chambers. These clocks lost only a fraction of a second every million years. Today, they live in satellites. Above us, circling the Earth, atomic clocks keep time for the global positioning system, the GPS in our cars, phones, and planes. Every direction we receive, every step we track, every time zone we cross, it all begins with cesium, humming silently in orbit. We do not see it. We do not hear it. But it is there, gently guiding the world. From sundials to water clocks, from sand to fire to quartz. We have now entered an age where time is held by the building blocks of the universe itself. Not because we want to be faster, but because we want to agree together on when things happen, on when to begin, on when to arrive, on when to pause. Time now is not just known, it is defined. It is morning. You reach for your phone. The screen lights up, and there it is, the time. Perfect, silent, instant. You didn't wind a watch. You didn't set a dial. You didn't adjust for daylight or distance. Time simply appeared. Welcome to the world of network time, where billions of devices across the globe are synchronized, quietly, invisibly, by distant servers and orbiting satellites. We now live in the cloud of time. Our phones update their clocks by listening to atomic signals from GPS satellites. Our computers check in with time servers every few hours. Our smartwatches buzz us when it's time to move, time to breathe, time to rest. Time is no longer something we track. It tracks us. Algorithms monitor traffic lights, trading floors, electricity grids, all orchestrated with unimaginable precision. Financial transactions are stamped to the millisecond. Planes cross oceans, coordinated down to the breath. Even the clocks in particle accelerators, measuring infinitesimal events, are synchronized across continents. And yet, most of us don't notice. We float in a sea of perfect time, unaware of the machinery beneath. There are no bells, no ticking, no gears, just quiet certainty. And while we've grown used to this effortless precision, something gentle remains. The truth that timekeeping, even now, is built on wonder, on looking up at the stars, on watching shadows move, on counting the seconds between breath and dream. Time has become seamless, soft, and ever-present. We carry it. It carries us. It is in the sky. It is in your pocket. It is in the hush between heartbeats. And though the devices may change, the impulse remains the same, to mark a moment, to know where we are, to remember what has passed, and to imagine what's next. Time has been measured in light, in water, in flame, in sound, in grains of sand, and in the hum of atoms. It has been carved into stone, drawn on parchment, etched into brass, encoded in satellites. But always it has been one thing, our way of listening, not just to clocks or calendars, but to life itself. We listen to the sun, to the sway of the moon, to the seasons, the tides, the ringing of bells in sleepy villages. We listen to the gentle tick of a grandfather clock in a hallway, to the whisper of sand sliding in an hourglass, to the soft buzz of a phone at dawn. And maybe, just maybe, we've always known that time is not something we must chase. It is something we rest into. It is there when we wake. It is there when we close our eyes. It flows through our stories, our memories, our silences. So now, as the world quiets, as the machines hum gently in the distance, as your breath slows and your thoughts soften, let time be simple again. Let it be nothing more than this moment. Right here, right now. There is nothing to count, nothing to fix, nothing to do. Just the sound of a story fading softly into sleep.